In this course, I'm going to discuss the clean architecture for the .NET Core 5 web APIs for the microservices. In the part 1, we discussed how the clean architecture should look like in the theory and what are the different projects, components inside each project and what are the file structure. And we also discussed some of the best practices, how the project should look like, and some of the principles. And now in this course, I will be focusing more on implementation, the clean architecture. So before I start, I would say thank you very much for attending this course. This course is going to take some time because we will be doing the actual practical end-to-end for developing the .NET Core web API. So I'm going to start with the Azure DevOps, start from creating the project, creating the Git repo, cloning the repo, and then once you clone the repo, you are going to create the web API and add folder structure to your web APIs with the endpoints. And I'm also going to add all the best practices like configuring the nlogs, configuring the Swagger and API versioning and asynchronous action methods. And then I will also spend time hosting these applications in the Azure as part of the Azure DevOps CI and CD. So it's a big agenda, but it is going to take a lot of time. So please bear with me and try to understand, because if you are working on the greenfield application, it is very, very important to take the right decision and apply the right changes. So without spending much time, let's begin the practicals. So before you start, make sure that you have installed all the required components. For example, you need the Visual Studio 2019. So this is like, you can have the enterprise version valid for 3 months, and after 3 months, you have to apply the license. And a lot of people use the Visual Studio Code. It is also pretty lightweight and faster as compared to the Visual Studio 2019. It all depends on your comfortness. If you are happy to use the Visual Studio Code as well, and also you may need the Visual SQL Server 2019. So you can download. This is a free software for the developer version, and additional softwares like Notepad++, Chrome. And if you are planning to have the spend time on the React and AngularJS, you need the Node.js for the NPM, and also have installed the Git so that you can use the Git Bash, Git CMD, and also if you are hosting the applications in the Docker. So I'm going to use all these tools throughout my journey. So that's why these are all recommended softwares. You keep it prior to start the work. Now, let me start creating the Git repo in the Azure DevOps. Before you start creating the Git repo, you need the actual project. So click on the new project, and then I will name it as AK Lab. So AK stands for my first name and the last name, and then give the repo and select the private and they create. I've already created this. So I just click on the AK Lab, and this is completely new and there is nothing inside it. Now click on the repos, and I'm going to, by default, it will ask to create the repo with the same name as the project, but I want to create the new repo. So as part of this repository, I'm going to create a new microservice. So in a microservice, you will be having a lot of microservices. And this is one of the microservice I will be focusing on using the .NET Core Web API. So let me, I have selected feedback service. So I'm going to create the feedback service as part of this Web API creation. So I will name this repository name as the feedback service and say create. And I've also included the README file by default, and it comes with the readme.md file. And this is how it look like. You can edit this so that as per your project requirement. And I'm going to do that later. But for now, I have the repository with the main branch. And now I would like to clone this. And this is my URL. So for cloning, I would like to use the git clone. So let me create the git clone command. So I have to enter git clone space, then the URL. Also, I need to have the path where I will be copying. So I already have that. So this is my git clone command from the main branch, B for branch, and I'll be saving that in the feedback service. So let me go and select the git cmd. I will always open this in admin mode. And then
from
say
desktop 9S1 QH31.
So let me copy that. There is some issue with the path. So this should say, this is the actual one. So there are multiple ways to clone the Git repo from Azure DevOps. So one, you can click on the Visual Studio Code and open here. So this will also take you to the folder where you want to. So this is how you can clone it. And I've already cloned using this earlier, I think. So I can say connect. Or you can use the git cmd and run the command to clone the git repo. So I will show both of them. So most of the time, for the first time, we will face some issues, but if you have done properly, then it should work without any issues. Not sure why this is taking some time. Yeah, now this is connected to the Azure DevOps. Now I see the main is connected. Now other way to clone is, let me go and delete. In other window, I have the services. I will delete that folder and I'm going to clone it again using the command. So now I cloned using the command without any issue. So these are the two ways you can clone the Git repo from the Azure DevOps to the locally. Now, if I go to my folder, so here is my feedback service with the README file. Now, since the Git repo is initialized, I can start creating the projects. So that's my next step, is to create the API project and then commit those changes into the Azure DevOps. So I have to start the Visual Studio 2019. I always open as an administrator. In fact, I always set this as running as an admin. So right click on the project properties and advanced, and then set run as an admin, so that you don't need to deal that with every single time. Now I just double click on that. It is opening in the right admin mode. Now I'm going to create the feedback service. So click on the create new project and then ASP.NET Web API. So you select the C# version. You also have the Visual Basic and F# version. So don't be confused with those. So make sure that you select the C# version. I'm going to name it as feedback service. And then the location I'm going to save is the C source repos, and I will call it as the feedback service. And then I place the solution and project in the same directory. So click on next. So this time I'm going to select the runtime, the latest, which is .NET 5. And then authentication, I will not be selecting any authentication for now. So I will leave it that. So I will also select the configure for HTTPS. So you might run into issues if we are hosting that into the the Kubernetes, but we will deal that later. And then I will also enable the Docker so that I will also get the Docker file by default so that I don't need to create that later. So I'm selecting the HTTPS, enable Docker, and then with the .NET Core, .NET 5, I've selected the project. Now this project is created in the same folder, the physical folder. I should make sure that the Git is connected because we already initialized clone from the server to the local. This should connect to the Git. When I click on the Teams, I should be able to see my main branch with 24 files. So these are the files added as part of the project when I created. Some of them are not required. I will handle those, hiding those files, not to commit those files for now. Let's run this. So I'm selecting the IIS Express. So let's build the project, make sure that this is working as expected. Okay, now I see the project is running, and with the latest template, which is your template, the Swagger is coming along with the template itself, which is good. So we don't need to explicitly configure that. It's not really hard, but there are some steps we need to follow to configure the Swagger. So by default, weather forecast API has been added here and here, and that's why we are able to see when we are running press F5, you'll be able to see that API endpoint is working in the Swagger. And if you want to try, just make sure that you are getting the response from the API, which is good. Now, I will have to look at the folder structure we talked about, part of the clean architecture. So I would like to make sure that all the folder structures are clean and working, created as part of this demo like this. So let me go back and see if the physical folder structure and the folder structure here are going to be exactly the same. Before that, I would like to commit the changes. As soon as I've done something, I would like to commit so that we don't lose those changes. So I don't want to commit all these folders by default. If you see how the bin is getting committed and also the other projects. So for that, we need to add the git ignore file so that all the files which are not required for the source code is going to be ignored. And I already have that in my other project, or you can Google it to get those files. So I'm going to add the git ignore file in the physical folder here. So go back here and add that outside. Now, when you come back here, so that number should reduce. Sorry, I have added the git attributes, not the git ignore. So let me go here, git ignore file. So the purpose of the git ignore here is, if you look at, so some of these files are not required part of the code. So these are all will be excluded from the Git, and also have the Git attribute. So this is to make sure that when you are running your code from multiple devices like, Android and operating systems, like, when you're switching but working on the same code, make sure that those are going to work with the help of the Git attribute. So Git attribute, Git ignore. So these are the two files you need at the root folder. Now I see this is my the Git repo name. Under that I have the feedback service. Actually, I would like to call this as the feedback service.api as per my folder structure. And I'm also going to have the feedback service.core, feedback service.infrastructure, and feedback service and the test project. So this is the project structure I'm planning to create it. Now let me quickly correct that the name, instead of feedback service, I would like to call it as a feedback API. So I just renamed the project feedback service dot API. I also added the name, corrected the namespace in these files, and make sure that the project is again working as expected. So I can see the project is feeling fine. Now I'm going to create the SRC and test folders. So I think we need to go to the physical folder here. So I'm going to have two folders, SRC for the source code. I'm also going to have one more folder called test. So this folder contains all the test projects, and this folder contains all the API projects like API core and infrastructure, and corresponding test projects will be inside the test folder. Now outside this, we are going to have Git attribute, Git ignore, and the solution and README file. So this is what I'm looking for. I'm going to close this so that I can move this inside the SRC folder. Now I moved inside. Now let's go and open the solution again. Since we moved inside, it will complain about the project. So I have to correct that. Now let me add this project in the same solution. Add existing project. I already have the project name. So under the SRC, I have the API project, and I'm going to select that. Now make sure this is working as expected again. Now no issues. Same as the physical folder, I'm going to create the projects for SRC. Also for my test cases. So I will call it as a test. I'm not sure whether I called it a test or test in the backend. So this should be tests. Now move the project into SRC. Now it's under the SRC. Let's build again. Now I'm going to add two more projects under the SRC. Create new project. This time I'm going to create the console. So console application, which is, sorry, class library, not console. Class library for the .NET Core. So this is the class library .NET framework, and this is the .NET Core. So I will name this as the feedback service .core. I just copy so that I can use that for the next time. So I'm going to keep this under the SRC source, right? So I will click next. Yes, I need the .NET 5 and then create. Same thing, I'm going to add one more project for the infrastructure, which is a new project. Again, class library. So I will select the class library, which is a C# version, and then I'll call it as the infrastructure. So this is again under the SRC folder. Now .NET 5, yes. So I have 3 projects under the SRC. Let's build all of them. So everything looks good. Now I'm going to add a test project here. So I'm going to use the XUnit, select the XUnit test projects, which is C# version, click next. Yeah, one of them I need, let me start with API dot tests under test folder, which is .NET 5 again. So this is my XUnit project. Let me add XUnit project, click next. I will call this as the tests. This is going to be used for core tests. Under test, I think I call it as a test. And finally, one more project, XUnit. And this time it's going to be infrastructure dot test under tests project. So this is how the folder structure. So we are going to add more projects, for example, the RM templates and also the performance testing infrastructure for the functional testing. So I'll discuss those things, but at the bare minimum, we need these many projects for source code and the API and the test cases. So let me build and then run again, make sure that I'm still able to browse the API, which is working fine. Now I'll make sure that the code is committed in the main branch before I start the remaining work. So I can go here, manage branches. So I think I will click on here, commit. Project structure added. So you can commit and push together. So I'm going to do the same. So now everything looks good on the Visual Studio. So make sure that let's take a look at what is in the folder, physical folder. So this is what I want, my service. Underneath, under the service, I have the API project, core project, and infrastructure project. Under tests, I have the API test, core tests, and the infrastructure tests, and these are the files. So let me create a new branch, make sure that always keep the working code. So I will call this as from the main, I will call feature hyphen folders or structure changes. So I'll just name it as feature hyphen structure. So I will keep the best practice always when you're working on any features. So make sure that, you know, naming conventions followed, feature hyphen, and the purpose of the branch. So I'm going to create this new local branch so that I can make further changes on the folder structure and add all the required files in the folder structure before actually adding the API endpoint. Now, let me also push these changes on the server for the first time and then keep working on. So I've pushed those changes. Those looks good. So let me verify. You can refresh here. Make sure that all your changes are coming along with the history. So that's the main branch. Now I'm working on the feature branch for the structure changes. So let's go back and then adding the couple of files on the UI project. These are going to be used. So I will add a new class for the dependency injection. I'm going to add dependency injection configuration. So you can call it as a configuration. So that's the lengthy name. So I just selected dependency injection in the UI. I also need key vault file. So I'm going to use the key vault in this API. So I will call it as the key vault cache because I'm going to cache the keys inside the API. So for that, I need the key vault cache. And then I also need the service description. So I'm going to keep all the description in the MD file. I'm not sure if I have the MD file here, but my file name is the service description. So I will explain why I'm adding this. I'm going to use that later. So it's a different file. That's the markdown file. Also need the Swagger configuration. So I will keep this Swagger configuration.cs file in the UI. All Swagger configuration is going to be moved here. So first I'm creating the files and then I will add the source code later. And you can also create a folder for the filters in case if you are creating the custom filters. So those are the kind of optional folders. I will not go more in details on that. Now I have the controller, so I just created the folder. I can also create a versioning here so that my API supports versions. So under V1, and I will also create V2 just for the startup, but I'm not going to spend a lot of time in doing that. I will move this under V1. Now API, make sure that this naming convention follows. So you can just select, create the naming convention like this. So under the APIs, V1 folder has the controllers and that has the controller. So same thing. So if you are moving weather controller here, that's fall under the V2. So I will expand that later, but I just create the folder structure V1 and V2. And that's all required for now in the API. And let's go into the core. Under the core, I also need the app settings here, app settings folder. So basic all the app settings I'm going to create under the app settings. So if your configuration is growing, you might need multiple files here. For now, I will add the simple app setting class. And then that's all I need for the API. Now let's move into the core. As discussed in the theory, the core is the heart of the API. So all the business logic and the abstractions are going to live inside the core, actual core domains. So I need basically a couple of folders in the core. For example, if you are managing the constants, all the constants are going to live here. For example, content type. So I just add one sample template. For example, content types. And then I also need the models. Models are my domain models. So I will add a folder called models, or we can call it as the DTOs. So models are the DTOs. So I will be using this folder for managing all the models. So you might need enums. Enums will be here. And then I'm going to keep the request folder for the request objects. I will also keep the response folder for keeping the response objects. I need another folder for helpers, and then need the interfaces. Helpers is optional, but definitely those are going to be used, as and when you grow the solution, those are going to be useful. I will add interfaces. As I mentioned, all the abstractions are going to live here. I will also add repositories. So this interface folder has the repositories and also the services. Services is the place where my service repositories will be living here, and all the repositories interfaces will be living here. Service repository will be placed here. Then I will also keep, in case if you are, I think if you're talking to external service from this microservice, so you can call the service client. So I'll come back to that later. But now under interfaces, those two are fine. Now I need another folder called services. So this folder contains all my business logic classes. I will add those files later. Now, if you want to add utils, you can add utils or helpers and the extensions, validation. So depending on as and when you start those folder structures. So single responsibility principle is very important when you are working on the clean architecture, so that as much as possible, try to create as many folders and organize your code and make sure that it's doing one single thing instead of mixing everything. So these are the folders required for my core. Now come back to the infrastructure. So in the infrastructure, this is going to talk to the database. So I need a folder called context. I also need a database folder for the entities. So I will call as entities. You can call it as the domain models or different naming conventions, but so I will call it as the, since the entity framework follows the entity pattern, so I will call the entities. And then my repositories are also going to live here, so I will call repositories, and then I need mapper. So I will say mapper. These are minimum folders I need. I don't need this class, so let me remove the class.
Frame from desktop 9S1 to H31.
Let me delete that. So let me make sure my project is still working as expected. So these are the folder structures required. Let me go and see. This is how it looked like in the Visual Studio, but in the here it will, yeah, you have all those projects came. So constants, enums, helpers, interfaces, everything came here, and same thing here in the infrastructure project. So that's how the folder structure will look like. Now I'll start adding the files in each folder. So since the folder structures are good, so let me add folder structures. Done. So let me push those changes so that I won't lose those changes. Now let's focus on the dependencies and the references required for the project. Now, API project has the dependency on core and infrastructure. Core doesn't have any dependency on here except the external or any NuGet shared package, and your infrastructure need a reference of the API. So that's the sequence. So let's make sure that we add those things as a dependencies. Right click on add project reference. As I mentioned, the API need core and infrastructure. So I will add those two in the core API. Now go back to the infrastructure, right-click, add project reference, and in code reference. As I mentioned, core will not be having any references within the project. Those are the project references. Now here also you can add API project reference in the text, and then same thing with the core reference in the core text, and same thing here in the infrastructure. So these are the project references. Now let's see what else is required. So in the UI, since we are configuring the Swagger, we should be having the Swagger by default with the new template, the Swagger Swashbuckle ASP.NET Core 5.6.3 came. So this basically has these are the 4 dependencies along with the Swashbuckle. So that means Swagger configuration is working as expected. And then going back to the core, I will also add the Newtonsoft. That's the library, the NuGet package, which is required from. So let me add manage NuGet packages. So click on the manage NuGet packages. Either you can search here. So I'm going to install from here, or you can take there are 2 ways. So you can copy this path and then you can add it from the console. So click on the tools and then you get manager console. Make sure that you select the right project here, otherwise you end up adding in other projects. So this is faster as compared to adding from here, but everything is fine. So since this is a user interface based, so that is preferable. But if you are using the Visual Studio Code, or you should be using the package installer console. Now in the infrastructure project, I need a couple of external dependencies. So let me go and add those through the manage NuGet packages. As I mentioned, this is easy for searching. So I need the auto mapper. As discussed in theory, auto mapper is one of them I'm going to use for this project. So I'll install the auto mapper here. The auto mapper is installed. I also need the entity framework core. Let me add entity framework core. So I'm selecting the latest stable one. And then I also need entity framework core dot SQL server. Okay, so I will keep adding as and when I start working on, but at the minimum, these are the minimum references I need for my project to start. Let's make sure the project is still working. Okay, so in the next step, I'll start adding the database model, the entity, and then the DB context, and also add the model in the core, and then interfaces and services and the controller. So I basically coming from the bottom to top while creating the files. That means I'll be adding the database entity, DB context, and then adding the model here, and then add the repository, map the model, and then add interfaces here, and then implement the service, and then implement the controller and run the controller action from the UI. So that's the goal. And let me add the model. So before adding the entities and the DB context, let me commit my changes. Added project references. So I can create the different branch if I want, but I'll continue working on the same branch. Now let's add my model here. So I'm going to create new item, say class. So I'm going to work on the feedback. So this is my feedback class. I missed the public here. So that's my feedback class. So I need the ID. So I'm going to use the int ID. So this is my primary key. So I will add as a key, and I need the using statement. And then I will also add required attribute. This is actually not required by default, it is required. So I'll keep it for just for the feedback, but I'm not going to use it for every other entities. So I also need the couple of other properties. So I already have those. Let me just copy those properties here. Part of the feedback entity, I need primary key, and I need the user ID. When I expand, you will understand why I'm using the user ID. And then subject and the message. So the rating, created by, created date, so modified by, modified date. So these are the common things we always have in the database tables. These are kind of optional. This is how my entity looks like in the entities folder. Now, let me create the DB context for the feedback. Right click on add new class. So let me add DB context here. The name of the DB context is feedback DB context.cs. And this is, I don't know why the public keyword is missing here. And this will be inherited from the DB context. Need entity framework code reference. And I need constructor. So I'm going to add one empty constructor. I think should be fine. So I'm going to add options of my DB context. So this is my DB context option. This is required for the base class. So I'm going to pass this part the base class. And then I need to add the DB set. So public virtual DB set of feedback. And then I will call this as feedbacks. I need getter and setter. So this is under the infrastructure entities. So that's the reference. So this is all I need in the DB context for now. I'm going to expand this DB context as and when required. Now let me see what is the next step. Is the adding the repository. So I'm going to add a repository and the model in the core project. I'll start with the repositories interface here. As I mentioned, implementation is in the repositories, abstraction in our interface is in the repositories, and the actual implementation is going to be here. So let me first add the interface. So I'll name it as iFeedback repository.cs. Again, I'm missing public here. That's my repository. Now let me see what is required for the repository interface. So I'm going to create the repository, create the feedback, delete the feedback, get all the feedbacks, get feedback by ID. So I already have the interface definition. So let me just paste those here. I need a reference of the feedback that's in the model class. So I need to create a model. So let me create a model in the model class. So this is the repository method basically returns the domain model after mapping the data from database into the database entity models will be mapped into the domain models and returned back to the .NET, the service and then API. So I have to create the new class feedback in the model. So right click and add new class. So this feedback public class will be pretty much same as the entity, but there won't be any ID here. So let me keep these properties, just copy paste to save some time. I don't need required properties here. These are my actual DTOs, data transfer objects, are visible for the consumers. So make sure that you expose what is required, not exposing everything. For example, you might not be sending these. The caller is only sending, even this is also, you might be reading internally. So only subject, message, and rating. These are the things you will be expecting from the request object when the HTTP request is sent to the API. These are the properties you will be receiving, and then going to map those into the database models and also add additional properties inside the database model. So when you are creating the new feedback, so you have to take care of all that in the mapper or in the service. So I will be explaining those in the details. For now, let's focus on this feedback class. Added the feedback class. Now go back to the repository, iRepository, and then fix the reference, added the code. Now this function getting all the feedbacks, list of all the feedbacks will be written, get feedback by ID. And some people I'm using the async, so you can also use the async at the end. That's a personal choice. So for now I will leave that as these. So these are the asynchronous methods. So this is the delete feedback. Now let me go and create the actual repository class in the repository folder. I will say class repository, and this is going to inherit from the repositories interface, and then you can also implement all the interface methods. I just use that option to implement all these interface methods. That's how you will be adding the interface, implementing all that. So let's focus on these actions. And before that, I'll complete adding the folders which are required for the service also. So let me go and add the service method. So now I'm going to add another interface in the services folder where the business logic will be sitting for the feedback. So this is my interface, public interface. I selected a class instead of interface. So I'm going to keep the same interfaces. For example, get all feedback. And this is again returning the core model. So let me fix that reference. All these methods I will be implementing inside my service. So this is under the interfaces. Now back to service. I'm going to add this time the class. Now this is going to inherit from the interface. Let me fix the reference first and then also do the implementation. Now I have the service class, I have the repository, and also the entity model and ATO model. Now go back to, let's make sure that this is working as expected. Now this time I'm going to create the new controller here. You can add API, empty controller, or you can add, let me add empty controller here. The name of the controller is the feedback controller.cs, and this is how I got the controller. Now I created all the files, pretty much everything. Now I need to start calling the files. So the controller will call the service, which is here. The service will call the repository, which is here. So that's the sequence I need to fix by using the dependency inversion principle. So I'll not be saying anywhere create new class. Rather, I will be using the constructor and adding the interfaces or adding the dependency inversion principle. So let me start from the repository, and in the repository I need the constructor with for the DB context. So let me use the constructor var and tab. That will give me the constructor. So here I am going to add the read-only property for the DB context. This is my feedback DB context. So I need a using statement, and I will always refer as underscore here, so that that's my read-only property. Follow the convention. So here I'll remove this, and then I need the mapping. So I will make sure that this is not null. In case of null, it will return the exception. So this is going to be useful for the test cases, for example. I also need the mapper, but I'll fix that part of the auto mapper explanation. So here I'm not adding for now. So I got the DB context. Now let me fix one of the code for getting all the feedback. What I need is the feedbacks from the database. So I think I need the auto mapper here. So let me first fix this one. So db context.feedback to list async and configure await. So this is my asynchronous method. So I see async is missing everywhere. So let me apply the async in these methods when I selected that default option. So it didn't kill. That's the drawback of. So now I got the async. Now let me fix the auto mapper. So I've already added the auto mapper reference in the infrastructure project. So what I need is the read-only property auto mapper, and then using statement is added here. Let me add this in the constructor. I'm going to fix this here for the mapper. That's the auto mapper. Now I need the system.link, I think the .NET Entity Framework. So that's about the get all method in the repository. Now go back to the service and call the repository method. So for that we need to have the read-only property for the repository, just like we did for the repository class. Here I'm going to add the constructor CTOR tab, and then I'm going to add the read-only property, just fix the reference using statement. And then I need a constructor adding here, remove underscore, and then just like we did a mapping here, I need the mapping for the repository. And then for getting all the repositories, here is the code for getting all the repositories. We just need to call the repositories. Again, async is missing here. Async. Just add the async here, and same thing here. Now my repository is ready. Now let's call this service is ready. Let's call this in the controller. So again, I need to go back to the controller, add the constructor, so TOR, and then add the read-only property for calling the service. Just fix the using statement here. Again, I need to pass this part of the constructor. I'll just fix this. Need the mapping. And now let me add the new API endpoint here and call the service method. So the API endpoint I'm going to add here for getting all the feedback. So this is how this is how the method will look like. So I just copy pasted, I've already done. So get feedbacks API, and this is going to return list of all the feedback. So let's fix the using statement, and I'm going to call the get all feedbacks. I've also configure await method, since these are asynchronous methods. I'll make sure that once the response comes back, I do the null check. If it is null, then return the null contents. If it is okay, then return okay response. I also need since this is the API endpoint, I need a couple of things here. Let me copy from my existing one. So I will keep the little description on the API endpoint. Also, I will keep what tables being used. So you can add as much as description in the API endpoint. I'm also going to use this Swagger operation later for the React consumer. For now, I'll just leave it the way it is now. So this is how my API returns 200 or the 400. So all these status codes are decorated in front of API itself. Now, if you debug here, it goes to the service. Service will make the call to the repository, get the data, back, map into the domain models. So this is my DB feedback, and this is the domain DTO feedback object. So that's how the feedback objects will be written. Let's see if the code still works. And if it works, then it should return the feedback controller. Yeah, that is working as expected. So that's how we will be adding the inversion. And now let me fix the mapping.